thanks so much for joining in on our first lesson with our off-site learning. I know that this is really different, but I'm sure that we will all make it. And I really, most importantly, hope that you're all staying healthy and maintaining social distances so that we can hopefully stop the spread of the coronavirus. But I spoke with Mr. George. He told me where you guys left off. He said that the last homework you received was your gram formula math worksheet. And so I wanted to pick up from there and start with our little lesson about that. We will also be having an opportunity for you to review your answers to the gram formula math worksheet and just some things to be aware of. So let's first start off with what is gram formula math. So ultimately, this is the do now you would have received if you had been in class today, but I thought it'd be good for us to start our discussion. And so gram formula mass is ultimately the same thing as molar mass. And so those two terms are used interchangeably. It's really important to note that because they will be used interchangeably and you'll be held responsible for understanding that they both mean the same thing. But really, what does it mean? So gram formula mass is the mass of 1 mole of any element, okay? And so a mole is, so mole, M-O-L, or that's the abbreviation. I know they take off the E. Thank you for saving us all that time. But 1 mole of anything is 6.02 times 10 to the 23rd. And so that's whatever you're measuring. It's a counting number, and it's because atoms are so teeny tiny that we need this huge number in order to measure them. But really, you can have a mole of anything. You can have a mole of atoms, you can have a mole of molecules, you can have a mole of elephants. But ultimately, it's a huge number. Imagine with this 6.02 with 21 zeros behind it. We're actually going to have a video a little bit later that explains to us just how big a mole is to put it into perspective. But going back to gram formula mass or molar mass is the mass in grams of any element of 1 mole of it. Okay, so it's mass per mole or grams per mole. And so the cool thing about the periodic table, this is another one of those like nerdy moments that Mrs. Ayler has, is that no matter what element you're looking at here, so let's take hydrogen, for example. If we look at hydrogen, I actually just want to look at the symbol here. Hydrogen has a mass of 1.008. So in the past, we've learned that actually represents 1.008 AMUs, which is the atomic mass units of 1 atom of hydrogen. Okay. Now, if you were to take that 1 atom of hydrogen and multiply it by the 6.02 times 10 to the 23rd, which is the number of a mole, and you have 6.02 times 10 to the 23rd atoms of hydrogen, that full mole of hydrogen would also weigh 1.008 grams. So an AMU is a really tiny unit. A gram is much larger. And that's the amazing thing about chemistry, is that 1 atom has the same numerical weight, but in AMUs, as 1 mole of those atoms. And so if you have this huge amount of hydrogen atoms, 6.02 times 10 to the 23rd, it only equates to 1.008 grams of hydrogen. And so even though a mole is a huge number, that just shows you how small atoms are, because a mole of hydrogen is still only going to be a little over 1 gram. Okay. And so that's what molar mass ultimately measures. So let's take this back into our practice. So if we look at the questions, if we were to calculate the gram formula mass or the molar mass of each of these, all you simply do is you take the masses of each independent element and how many there are of them and add them together. So for example, if we go here to our whiteboard, let me erase, maybe not. Oh, I got the alert that we're going to lose connection in 20 seconds. So why don't I answer the next question on the next video? Thanks, guys. See you then.